Advanced Financial Modeling, Topic 5, Fixed Income Portfolio Management, Learning Objective number 7. We're going to create hedges for a levered bank portfolio. So we're going to go to the spreadsheet and we're going to talk about this particular bank model. So before we go there, let me just explain what you're going to see. This bank is choosing to buy $10 million of assets. You can see the assets are a bunch of auto loans, a bunch of home equity lines of credit, and a bunch of mortgages. I've given you the prices, the yields, and so on, and the total values of these bonds and quantities. So you can see they're buying 45 auto loans, 60 HELOCs, home equity line of credit bonds, and 85 mortgages. Notice I didn't use Excel's duration and convexity or the VBA duration and convexity. Since these are mortgages, they will require other models to get durations and convexity. So I just put in some values there. And what you see is the weighted average duration of the $10 million set of bonds is 3.3 years with convexity of negative 172 and generates $894,000 a year in income. So those are the assets the bond or the bank is choosing or wants to purchase. How they're going to fund that purchase is they're going to use $1 million of equity. This is the equity line. And they're going to use $9 million of debt. And the debt is just going to be issuing a series, either 1, 10, or 30-year bonds. Just normal bonds. These are just the VBA functions for duration and convexity. What I've done here is I've entered in just the simplest solution. If they want to issue $9 million of debt and $1 million of equity to buy the $10 million of assets, what if they just buy 30 of each of the quantities? That'll get me my $9 million. If they do that, what we're going to do is compute that the equity, that $1 million of equity, the net position is their long $10 million of assets and their short $9 million of bonds. That $1 million of equity, if I take the weighted average duration, it's negative 23 units, and the weighted average convexity is negative 2,500 units, and their total interest income, including the interest they're receiving from the assets and the interest they're paying from the bonds, is they're going to make $249,000 a year. So let's take a look at this spreadsheet, and then we want to try to optimize the spreadsheet and think about also the risk profile. So I'm going back to the spreadsheet. They're going to buy these assets that have a total value of 10 million, duration of 331, and convexity of 172. If they issue 30 1-year, 30 10-year, and 30 30-year notes, that would generate $9 million. That has a duration of 6.24 years and a convexity of 89 years, or a convexity of 89 units. And there's the income. So what is the total equity? Well, if you have assets and liabilities, is a negative number, has equity of 1 million. I can also use that formula to show the total income that's going to be generated, $249,000 a year. Notice the leverage. You have $10 million of assets funded by $1 million of equity and $9 million of debt is 10 to 1. And I want to calculate these two numbers. What is the duration of my $1 million net portfolio? Well, it's just going to be the weighted average of assets and liabilities. So all I need to do is take open bracket, that duration of liabilities times the market value of liabilities plus assets first and then liabilities, and then I'll divide by the total sum. So it's just a weighted average. These are the assets, these are the liabilities, this is the total. So that gives me a duration of negative 23 years. All right, now this is a levered portfolio, so and we'll talk about what that profile means. And we'll do the same thing. I'm going to copy these formulas, so I'm going to anchor. Well, we'll just do the formula again. We'll take asset convexity times asset value plus liabilities divide by the total, and there's my negative 25 units of convexity. So that's my portfolio. You have $1 million portfolio with negative 23 units of duration. Now, what does that mean? When I do the simple weighted average, it says it has negative duration. What that means, first of all, negative duration. First of all, normally when you get a duration number, the number is positive. That means there's an inverse relationship between price and yield. When the rates go up, the value goes down. When it's negative, it says it's the opposite. When rates go up, value goes up. So it's flipped. And it's really large, meaning that plus or minus 100 basis points, you're going to gain or lose 23% of your equity. And it has negative convexity. That means, remember, the risk profile droops down. So here's what the picture looks like. This is what negative 23 units of duration means. And what I did here is I just went ahead and calculated the base case portfolio is $1 million. And then if you see, if rates are down 100 basis points, I just used minus duration times change in yield plus 1/2 convexity times change in yield squared times the total value. And you can see that when rates go from 0 to down 1%, the equity falls, and then it falls again with 200 basis points and falls again with 300 and 400 basis points. So you can see here's what the risk profile looks like. And also, if rates go up a little bit, you gain a little bit. That's the negative duration. So this has negative duration. When rates go up, actually the value goes up by a little bit. However, because of this negative convexity, this function is drooping downward. So this is a picture of negative duration, which is a positive relationship between price and yield, and the droopy negative convexity. So it doesn't look too good. If rates are down 200 basis points, looks like we're bankrupt. Equity is less than 0. And if rates are up somewhere around 300 or 400 basis points, we also go bankrupt. All right. So this is an ugly picture because there's lots of negative convexity in the assets, which is creating this droopy risk profile. So what we're going to do is see if we can do a little bit better than this. All right, so again, right here, it looks like we're going bankrupt when rates are down 200 basis points or when they're up, say, 3.5. So what I want to do is I want to run an optimization, and I want to find that what if I try to eliminate that duration risk. So what does that mean? The equity duration was negative 23 units. What if I try to get the equity duration to 0, minimize the risk? It's like setting durations of assets and liabilities equal to 0, but since we have an equity number, we can just set equity duration equal to 0. So let's try to do that. Data, solver. I want to set equity duration negative 23 units to a value of 0 by changing the quantities of bonds I'm going to buy. I need to uncheck the box since since we're issuing these bonds, it's going to be negative. I'm going to add a constraint that all those weights have to be less than or equal to 0 because I'm issuing these bonds. So I'm setting equity duration to 0 by changing the quantities, uncheck the box, and make sure the quantities are either 0 or negative, they're non-positive. And I'm also going to add a constraint that equity is equal to $1 million, or I can set a constraint that liabilities are equal to negative $9 million. So either one works. So I'll say equity, or I can also say that leverage is equal to 10. All those work. But we'll just say that equity is equal to 1 million. And let's just make sure I have enough zeros there. And let's see what solver gives us. Hit OK. Solver found a solution. And if we now look at what happened here, notice that this is a little bit different. It's flatter because duration went to 0. So the picture used to look like this with duration of negative 23 and drooping down. Now the duration of 0, it's flat. Remember, duration is also a slope in another way of thinking about it. And it droops a little bit less. So now it looks like I'm not bankrupt if rates are down 200 basis points. It's 300 basis points. So this is a better solution. Now I went from going bankrupt when rates are down 300 basis points to 200 basis points to now it's 3. So we just made this shift of this is moving out this way. This one used to be out here. That shifted in a little bit, but I think it's better with this solution because it takes a larger change in rates for the organization to go bankrupt. And I could do one more. What if I really want to maximize or minimize the risk? I could run a solver that maximizes convexity. And what we'll see, it's a little bit better as far as the risk profile. Solver, I want to maximize convexity. I'll maximize equity convexity at 2,100 units there. And I want to add however, I still want to keep it, we call it duration neutral or duration matched or 0 duration, and add a constraint that equity duration is equal to 0. So now I'm maximizing equity convexity by changing the quantities. The quantities have to be non-positive. The equity is equal to 1 million, or you can put the liabilities are equal to negative 9 million. And the J12 is less than or equal to 0. All right, I'm sorry, is equal to 0. That should be equal to 0. All right, I'm setting duration equal to 0. Solve, okay. And what you'll see is this just a little bit better than before. If you actually look at the risk profile up and down 300 basis points. So this is how you hedge a levered banking organization that holds a lot of instruments with negative convexity, namely mortgages and equity lines of credit and auto loans and things like that, because of and the reason they have negative convexity is because of the prepayment of those instruments. So that's how we hedge banks. That's how banks hedge interest rate risk.